We're going to cover the first part. Let's see, there we go. The first part of 5-4 today. If I can get my slide thing to work. Okay, so we're going to know today we're just going to do rectangles. Our objective is to know the characteristics of rectangles, and then we'll do squares and trapezoids next time. My iPad's a little slow today, so alright. So the first definition, rectangle, is a quadrilateral with 4 right angles. Quadrilateral with 4 right angles. A and B in the picture are supplementary angles formed by the transversal AB. So we A and D, AD and BC are parallel. Similarly, we can say that AB and CD are parallel. So therefore we can say that the rectangle is a parallelogram. So it's using CIA here. We know we have right angles. These two angles are supplementary. So that means these lines are parallel, and then you've got this angle and this angle are right angles. They're supplementary. So by CIA we could say these two lines are parallel, and then by definition the rectangle is a parallelogram. So that's our theorem here. Every rectangle is a parallelogram. Because every rectangle is a parallelogram, we also know that the opposite sides in the rectangle are parallel. The opposite sides are congruent, and the diagonals bisect each other. A rectangle is a quadrilateral with 4 right angles. However, if we know that a quadrilateral is a parallelogram, the following theorem holds. A parallelogram with 1 right angle is a rectangle. So if I have a parallelogram and one of its angles is 90, we know the other 3 are 90 as well, and it's going to be a parallelogram. So this gives us an alternate definition for a rectangle. A parallelogram with 1 right angle is a rectangle. The diagonals of a rectangle are congruent. This isn't true for any parallelogram, just for a rectangle. The diagonals are congruent. So if ABC is a rectangle, then AC is equal to BD. Diagonals are congruent. So we have an informal proof of this would be, so I have a rectangle. In the rectangle we know AB is congruent to CD because the opposite sides in a parallelogram are congruent. Alright, so we have AB congruent to CD, and then angle BAD equals 90, degrees. And angle CDA is equal to 90. Because it's a rectangle, right? So we know these two are 90. Then we have AD is congruent to itself. So we've got that congruent. And then, if we draw in the lines, AC and BD, now we have side angle side, right? Side angle side of the BAD is congruent to side angle side of CDA. So triangle BAD is congruent to triangle CDA by side angle side, and then as a result we can say the diagonals are congruent. AD or AC is congruent to BD, and that's by CP. Alright. Does the converse of this theorem hold? With the converse, so we have a quadrilateral, the diagonals are congruent. Does it have to be a rectangle? What's a counterexample?
Could it be an isosceles trapezoid?
Yes, very good. The answer is no, because as Shatiz said, it could be a isosceles trapezoid. This is a counterexample. The following theorem, however, is true, and that is, if a parallelogram has congruent diagonals, it is a rectangle. Okay, so if it's a parallelogram and the diagonals are congruent, we know it's going to be a rectangle. So we're given parallelogram ABCD with AC equal to BD. We're going to prove ABCD is a rectangle. You can refer to the picture. Let's do the proof. What would be my first statement, Shatiz?
ABCD is a parallelogram?
Yeah, well, the given part. So ABCD is a parallelogram with AC equal to BD. And that's given. Step 2. AB is congruent to DC. How would I know that? Somebody else. How would I know that AB is congruent to DC? Yes, Ben. Definition of parallelogram is opposite sides are parallel. Wouldn't be definition of parallelogram. Okay, Shatiz.
The opposite sides of a parallelogram are congruent?
Right. Opposite sides of a parallelogram are congruent. Alright. What do I want to say by reflexive property? start calling on people here. Let's see. Elisa, what do I want to say by reflexive property? Okay, Shelby. AD is congruent to AD. All right. Okay. What can I say now? Shelby?
I was just going to say, I said
BD?
BD. Yeah.
That's not going to help us. We already know. We don't want to say BD is.
Like for step 3.
Yeah, step 3. BD congruent to BD doesn't help us. We need to say AD is congruent to AD. So hopefully you're marking the figure as we mark these things congruent, right? What does this lead us to, Chris?
The triangle BAD equals CDA.
By what? Which shortcut?
Side.
Yeah, side. Triangle BAD equals triangle CDA. That's by side. Okay. Angle BAD congruent to angle CDA. How do I know that? Abby. CP. Right. I know that by CP. And what are we going to say by consecutive interior angles? Emma, what would I say with CIA being the reason?
That angle CAD is congruent to angle BDA.
That may be true, but that's not going to help us in this proof. Look at step 7. In step 7, we're saying angle BAD and angle CDA are right angles. Right? And I know that from the previous 2 steps. So what would fit in at step 6, Nina?
Would it be angle DCB and ABC?
No? Shatis?
Angle BAD plus angle CDA equals 180 degrees.
Right. Okay. Angle BAD and angle CDA are supplementary. Right? So what it's getting at is they're congruent and they're supplementary, so they have to be right. That's what step 7 is saying. Then how do we know that we have a rectangle? Step 8, ABCD is a rectangle. How do I know that, Hicha? Definition of rectangle is if it's a quadrilateral with 4 right angles. We haven't shown all 4 angles are right. Julia, what do you think? How do we know it's a rectangle? Definition of parallelogram is that both pairs of opposite sides are congruent. We already know it's a parallelogram. Nick?
Parallelogram with a right angle?
Yeah. Step 8. It's a parallelogram with a right angle. Is a rectangle. Everybody have it? Given a rectangle ABCD with AB equal to 3 and AD equal to 4, we need to find AC. So AB is 3, CD is 3. Okay, we need to find AC. How would we find AC? I already did the first step. I made the opposite sides congruent. So CD is 3. So what's AC going to be? Aditya? Why? Yeah, it's a Pythagorean triple. Somebody will let her in. So yeah, we've got 3 squared plus 4 squared equals BD squared. So that means BD equals 5. And then, BD is equal to AC, right? Because the diagonals are congruent. BD equals AC. So that means AC equals 5. Okay, any questions on today's notes? No questions. All right.